Hello everyone. I hope that you already have watched the previous video where we have discussed about the boosting technique and its core idea. In this specific video, let's try to focus on the difference between bagging and boosting and stacking. So I hope that my screen is pretty much visible to everyone, and you can see that there is a appropriate diagram which we can see on our screen, and the difference between these 3 points on the basis of the purpose, the base learner types, base learner training, and the kind of aggregation which we are doing. So let's try to understand it step by step, that what is the difference between these three on the basis of these four aspects. This can also be asked from you in an interview, right? So please make sure that you will be able to understand the core idea behind these three techniques and the internal difference between these three techniques, right? One important thing, one common thing is that all of them are a part of I would say, ensemble techniques, right? All of them are a part of ensemble techniques. And if you remember, what is the meaning of ensemble techniques? That multiple models are working internally in all of these three parts, whether we are talking about bagging, or we are talking about boosting, or we're talking about stacking. Now, the question is that how these three techniques are different, and all the concepts lies inside the core idea only, right? What is the core idea behind bagging? What is the core idea behind boosting? What is the core idea behind stacking? If you know that, you already know the answer, that what is the major difference. So maybe before you will proceed and discuss and see the video, pause it and think over it, that whatever things you have learned so far in this course, in the previous videos also I have showcased you the concepts. What do you think is the difference? And then maybe you can just rewatch this video and check it out, that whatever points you have thought that these are the differences that we have, are we on the same page or you are missing somewhere, right? First interesting thing is that when I was talking about bagging, if you remember, I was telling you this point, that bagging people usually prefer whenever they want to reduce the variance. When I'm saying reduce the variance, major purpose is to avoid the overfitting, right? Overfitting. So if you remember, overfitting comes whenever we will be having a high variance. So I'm just writing it here so that it will be pretty much visible to everyone. So to avoid the overfitting, so to reduce the overfitting, in other words, to reduce the variance, right? Overfitting means we want to somehow reduce the variation or a variance in a given model. Does it make sense? That is why, if you remember, one of the very famous bagging technique named random forest is being used because it was the savior for a decision tree, where decision tree was again and again suffering from an overfitting problem, right? Do you remember random forest lecture? If you don't remember, please refer that again. In that video, I was just demonstrating you that how basically the problem that we encountered in a decision tree where overfitting was there, this random forest will be able to overcome that, right? With the help of this bagging technique itself, where we will be having multiple decision trees working together with the help of this n underscore estimators parallelly and giving us a result, right? So this is the main purpose. Whereas whenever we're talking about boosting technique, it is specifically helpful to reduce the bias. What does it mean? That this is basically tries to reduce the, I would say, underfitting in a model. Reduce the reduction of the underfitting. What is the meaning of underfitting? I hope you all remember that bias is very high. So reduce the underfitting. In other words, we want to get a reduction of the, reduce the bias itself. Because in the training set itself, we have a weak learner. Means when I'm saying weak learner, it means that my model will not able to understand the given data altogether. So how will it behave better in the test set data, right? So both of them serves a different purpose. In bagging, our focus is to reduce the overfitting. In boosting, our focus is to reduce the underfitting. And if you remember from our previous sessions, whether it be overfitting, whether it be underfitting, both of them are bad for us or bad for our model. Both of them are error, because in overfitting we have high variance, in underfitting we have high bias, but in a ideal situation, in a, you can say, perfect scenario of a model, what we want is a low bias as well as low variance, right? So that is where bagging and boosting serves the purpose. Where stacking is used? Stacking simply used to improve the accuracy of the model, where we know that it usually combines multiple different variety of models, take the predictions of that model, and then we apply that predictions to the next layer of the models. So predictions are somehow combined together to form a better prediction. So it will somehow improve the accuracy of the model in the stacking part per se. Right. When we are talking about base learner types, we know that in bagging and in boosting, both of them serves a homogeneous model. When I'm saying homogeneous, few minutes back only in the previous video I have talked about that we are somehow dealing with a similar type of models here. But whenever we're talking about stacking, it serves a purpose where it is having a different variety of models. If you remember in our previous discussions, in the previous videos, in the M1 part, we have taken KNN model. In M2 part, we have taken SVC. Do you remember that? So in this case, we don't want that, okay, everywhere I will apply either decision tree or I will apply either KNN. I can take multiple varieties of models and curate a layer by layer things on top of that. Whenever we're talking about base learner training part, we know that in bagging, parallelly things are happening. So parallelly, we are somehow using 5 decision trees or 10 decision trees or 100 decision trees by default, which is the number of estimators, right? So what is happening is we are using the same model, and what is happening, it will take randomly with replacement data points in a given data, and it will try to do the training part. And at the end of the day, we know that while aggregation, depending upon what kind of problem we are solving, if it's a classification, internally it will apply max voting. If it's a regression, internally it will apply averaging, right? We know that. But in boosting part, just few minutes back in the previous video, we saw that it's a sequential based learning, where first model will give me the result, model evaluation will happen, how many of them are correct, or you can say correctly classified, how many of them are wrongly classified. Whatever the wrong predictions my model is giving, that is something which we will send to the upcoming model. And this flow will keep on going until we reaches to a point where we will be able to cater all the almost correct predictions altogether. Make sense? In this particular case, aggregation will be done via weighted averaging, right? This is what we will see in the upcoming part of the videos, where I will talk about the internal logic of these algorithms that we have. And then we will see that how combining together all these predictions with the help of this weighted averaging, we will be able to get the result. Whereas in base learner training, we have one meta model. Do you remember when we are doing the implementation of stacking, when we were applying M1 as KNN, M2 as SVC, we got the predictions. We try to give those predictions as an input to our meta model, which is random forest, right? So that is something which we call as meta model in a stacking. And again, the final result was the weighted averaging of all the predictions that we are getting. So this is the overall idea behind the difference between bagging versus boosting versus stacking. I hope that this is clear to everyone. If you still have any confusion, please make sure that you will be able to clarify that, right? This bagging and stacking, we already have covered up in detail that how the internal working works, or what is the mathematical intuition behind the same, how we can do the implementation, right? Via the code part. Everything I think I have covered up in my previous discussions. In boosting, still things are left. We will talk about each and every algorithm in a lot more detail in the upcoming videos. So if anything is not clear, please don't worry. We will discuss in a detail, and I think you will be able to get a better idea at that point of time. But anyhow, I just want to give you an intuition that how they are different from each other, because this is one of the mostly widely asked interview question also in a product-based company. So please make sure you will get a better understanding now. With this, let's end today's video, and I'll see you all in the upcoming video where we will deep dive now into this boosting techniques that we have. Bye-bye everyone, and see ya.